Hello, everyone, and welcome to our script coding session today. My name is Clarence, and I'm from the TikTok House team, and also I'm one of the developers of the House scripting feature. Yeah, so the good news is that we are going to release a bunch of templates demonstrating the script component recently. So today we are going to take a look at one of them, which is called collision prediction. Yeah, so although I'm not going to start from the scratch today because you guys can see there's already the hierarchy, the scene hierarchy built, and also we have the assets. Like we assume that we already have the assets made, like the textures and physics materials for collision. But yeah, the major point for this video is to go through the script like step by step. So I'll comment out almost every line of the script, and then I will add this back to it step by step and demonstrate how APJS API works for this type of like a typical 2D physics-based game. And yeah. And some brief introduction about this game is that the goal of the game is very simple here. So to predict when to drop a vehicle to hit the kind of like the spinning gold bricks here, and you can see. And then if it starts from the skateboard, and if you release the skateboard, and then it will fall down and hit on the gold bricks, and it will bounce from each other, and then whenever it hits, you will increase the total points, actually the value of the actual vehicle, and then change the texture of the vehicle until it gets to the sport car. And yeah, and if the vehicle fall off the screen, the game is over. Yeah, so that's about it. And let's get started to look at the TypeScript here. So you probably already know how to create a script from here. And then if you create a script, and you can also put it into a subfolder here in the assets. And then when you click on it, you can see this like kind of like the preview of the script in the inspector panel, and you can definitely open it in the VS Code. And yeah, and the code is already here. So I'm gonna explain how these code work in this template. So yeah, let's start by the serialized property. So I will uncomment one of the serialized properties. So the first one is the score on hit, which is actually telling you the scale of how much score you will add whenever it hits on the go break. So this is very easy to understand, but I think this is the first time I introduced the serialized property here. Yeah, as we can see, like if you mark this decoration here as the serialized property, and you can definitely see like the documents of explanation how this will work to serialize this property into the UI of the inspector panel if you attach this to um, a component. Let's see, we can save this, and then you will immediately see this property that is revealed on the component UI. So you can adjust this because this is a slider. And if you want to use a slider, you can use this decorator slider, and you have the range here, minimum and maximum value, and also the kind of like the step of how much you will increment when you slide on slider. Yeah, and which is very intuitive. And yeah, we're gonna see all other serialized properties in this template script. And we are gonna have the spinning speed of the left side brick, and also the spinning speed of the right side brick, and also the vehicle level icons, which is the list of the icons corresponding to each of the different levels of the vehicle. and also vehicle score on hit. Yeah, and which means like kind of like the ranges for each of these vehicle levels, kind of like how much hit will you need to be in this level. So let's save this change for this serialized properties, and you guys can see like these properties are shown here. So we can set up a default value here, like the two and the empty array here, and then you can actually add elements of these. So like the vehicle icons. So I will add each of these one by one, and then we can see skateboard. That's the order of the levels. The second one is a bicycle. The third one is which one? Motorcycle. And taxi. A car. Let's see. So that's 6 levels of the vehicles. Okay, so the vehicle scores on hit. And this is kind of like very kind of free values here that you can set. As we can say, like it will determine how fast the value will increase when, as your vehicle bouncing from each other on these two bricks. So let's see, like 0 to 1 is the skateboard, and as long as you can set a like scores on hit to be a very low value, like the 0.01 or 0.2 here, and then every time it hits, it will only increase 0.02 as the score. So if it is rangeful into the 0 to 1, it will still be the skateboard, and after that, it will, let's see, like 1 to 5, let's say, it will be the level 1, which is the bicycle. And then let's see, I'm like, we don't want this to overlap, so let's make it like this. Or you can basically actually in the code, we can do that. And then 5 to like 10, or 10 to, let's make it bigger, 20, and then 20 to like 40 or 50, and then 50 to like 100. Probably that's too much, but we can set it for now and then see how it goes, and we can adjust that later. And the vehicle object, we already have these objects in the scene hierarchy, so we will set each of the corresponding scene object here in the inspector UI, which is much more convenient than before, because we before we support this, we have to use the define object in the scene by the name. Yeah, this is the following vehicle, and recording text is the text that hints us to start recording. So the recording text, and we'll toggle this off when it starts. And then current score is the score that is show up here. So let's see, the current score is here. And then the falling detection area is some object that we put it at the ground, and see like this here at the bottom of the scene, so that it can detect the vehicle that is full off the screen. Yeah. And next one is the final score vehicle. We want to show the final vehicle that as the final result of the game when the game is over. So it should be final result vehicle here. And then the gold bricks to the left. Right. And also, yeah, that's done for this UI part. And yeah, and you guys might already see we already have this like kind of like the physics component setup, like the collider 2D and falling vehicle has the rigid body 2D, and the rigid body 2D has some um, coefficients here set up, like the, yeah, and for injection area, of course, we already have the box collider 2D. So these are very essential parts. And we will demonstrate um, how the collision works in the APJS API and also the collision events that we support right now. So yeah, let's go to the next part. And remember to save the project as you go. Okay, so the next part are those private variables. Actually, you can set this as private as well, because even though it's private, it can show up, it can also show up in the UI. It doesn't have to be public, but I set it as public, as you guys can see. You can also set up a group, which is here, showing up a group begin, and you have a like a title of the group here, and then you can see like in here it will show up a group name like this object configuration, and if you release that, it can collapse, yeah, or expand, yeah, at your convenience. So let's see the private variables here. I will uncomment these variables. So right now the animation hasn't been encapsulating to APJS API yet, so we will have to implement that in the code manually right now. So in this template, I have already included some of the essential calculation functions of the animation so that you can take a look and for reference for your for your effects. So this is kind of like a typical parameters that we need, like the visual transform, because we always operate on transform to change the position or scale or anything like about the transform and to make it like looks different. And then um, it does need some like kind of like the Boolean variables that we can do it later in the on update callback so that we will move or animate the object. And also the pinning duration, if you have a ping pong animation, we'll have two states, one is pinning and pawning. So this is to mark whether this is pinning or pawning, and also the pinning duration is the half of the entire duration for one period of that ping pong animation, and also vehicle animation time that is recording the total time that is in the animation, and start position and position, because these two are kind of like fixed positions in a scene. So we already have this like pre-calculated in the scene, and we want this skateboard to ping pong from the left side to the right side at the beginning of the game, and that the player to see like when to release the skateboard to start the game. So yeah, so let's see how this is working to set up the animation. Yeah. Also, as I mentioned before, we have the mathematics calculation functions here. Right now we have to implement that in the user script, but in the future, I think we're gonna move these to the APIs so that you guys can reuse this quickly and conveniently. So yeah, but right now we um, include these calculations of how the Bezier curve works and how the combination, like the binomial coefficients, with the memorization to optimize the performance, and also the cubic Bezier curve so that we can animate the objects not just with a single speed or unchanged speed. We can change the speed as it goes, and just like the graph transit by time node, you guys have the options to like kind of like to animate it in the variable speed. So this is how it works. And also we're gonna have the get current number on this interpolation of the Bezier curve like this. During this progress, we will have a t here, and then get the real-time value when the t goes to any place. And also we are gonna have the get current value here to get the actual value when each of the x and y are interpolated by the Bezier curve and wrap it into the vector 2f. After the mathematics calculation functions as the utility functions, we're gonna take a look at how the onStart works here, because it will initialize all the state of the games. And let's take a look. And yeah, the first step is to get the screen transforms and like the rigid bodies or other components like the central components, and for these kind of like the private variables that we're going to use across the script. And you have several ways to do this. One is to from the vehicle object that is serialized object, you can get the component by the name, which is called scene transform. But also there's another way. It's actually you can get transform directly like this from here. So but you have to convert that as the screen transform so that it's gonna be easier later to set up those parameters because it's a 2D scene. And also other things like colliders can be got from the vehicle collider object, of course, and also the icon. Icon is the image type, and also here is the essential part. Okay, so we're gonna support the collision event in 5.5.0 here. And how does it work is that if you get a vehicle collider here as the any type of collider or collider 2D or a 3D physics collider, you can set this parameter, which is called emit collision event, to be true in the onStart so that it will be activated. And otherwise the physics system won't detect the collision. And after that, we're gonna have the emitter to be the like the use the event manager to set up the object emitter, and then use it to turn on the subscription of the event callback when there's a collision event happens. So this is how it works. And whenever you have the subscription set up, you can use a function or use a kind of like a something like this, uh, a property typed function like in the TypeScript like this, some kind of like a property that equals to some lambda function here. But this is a little different from you use a function directly, because this pointer will be kept if you use this. But if you write this as a function, like a general function that like these, you will have to pass a third parameter as this. You have to pass this because function types will lose this pointer. Yeah. But right now you don't have to because we are using the parameter typed function. So this is how it works. We will have the collision events callback function set up like this. It will pass in an event which is APJS I event, and we'll have the collision infos as the argument, um, and we'll cast the type to be collision info 2D, and in it we will have the other object information from the other object from the info, and then if the vehicle is still falling, we will detect whether there is an kind of like effective hit, or the game is gonna be over when the falling detection area at the bottom of the scene is collided. Yeah, as you can see, there are some logics here, and I will make this kind of like effective step by step and let you guys see how this works. And whenever it hits, we will update the check to update whether we need to update the vehicle icon, because we might have the level up when it keeps hitting, because every time it hits, the score will be incremented by some certain steps that we set up in the game configuration. So here is the update vehicle icon. I think the first line is still common. And also this one is the update vehicle value. So every time we hit, we will do these two steps to update the vehicle's state, which is the icon itself, and it will check the range that we already set up here, like this, and then to see whether the vehicle is still in the same range as the score goes up. And if it falls to the next range, we will change, you can see, change the current level here, and then replace the icon with the list of the icons that we have reset up as the resources here. And we will replace the texture by calling this a vehicle icon, which is a apjs.image type texture, and then set up this icon in here. Okay, and the update vehicle value is rather simple. We just update the text here, and if you guys find any problems that the APJS text, like you can get the component again whenever you change the value of the text, before you change the value of text here, and to avoid any problems. But yeah, we'll make sure this will work. And we'll have 2.5 times this number. This is just very kind of like a number that we randomly set up to adjust whether you want to get the numbers quickly or slowly. But yeah, this is you guys can adjust it as you want, and then display the K dollars here. And yeah. Okay, so in this onStart, we also gonna set up some other state at the beginning of the game. For example, like the rigid body. So in the rigid body, there's a important parameter here that is representing the kinematics here. So which means if this is toggled to be true, that means it's not gonna be responding with the gravity or something. But if it's not static, it will fall down. Basically, if at the beginning of the game we want to let this skateboard to move as the animation, we don't want it to respond to the gravity, so if set up to be true as the initial state. And also, of course, the several in the several essential callbacks for on record start, on record end, and on touch event. So here's the thing. The on touch event, maybe if you guys watched my previous video, you're probably already familiar with this. So on touch event is a callback function that we set up here. This is also a parameter type of function to eliminate one extra this that we caught, but um, yeah. So the touch info we can get from the event arguments, and also touch info.phase, and when this is the begin phase, and we will, that means when you tap on it or just to click on it, and the vehicle ready will be immediately, if the vehicle is ready, and then the vehicle will immediately start to fall, and the vehicle rigid body, we're gonna toggle the static to be false because we want it to fall, and then it will needs to be responding with the gravity. Yeah. Okay, so that's the untouched event, which is very simple. And the thing is that there is also a on-record start and a on-record end callbacks that we can subscribe in on start. So the record start and record end corresponds to when you click on the start recording button. And usually we will need to do something when there's a record button clicked, and also when the recording state ends. So this is very similar with the graph systems, kind of like the reset on, record on or off, because in a script, everything is in a code. So we won't have the kind of like the universal reset for each of the kind of like the variables or the parameters that we are using, or any properties we set up here. We will need to manually pick the necessary ones when the record ends or when the record starts to reset, or reset to some state that we can reset the entire game state, so that the player can restart the game. Yeah, as we press the button. So here is one example here. So if the record starts, we will make the game ready to be true, because it's ready to let the player to click to tap the screen and fall down. And the text enables false, which is the hint text can go away. And when the record ends, we want to reset the entire game state to the initial state. So we manually picked some of those essential parameters and also the properties here to set this to be the initial state, so that people can restart the game from the beginning, set up this to 0, and also make this texture to be the default ones, and the text to be the default question mark here, and something like this, and update the vehicle icon according to the initial state. Yeah, and I think this is, yeah, it's kind of like everything we do in the on-record end. So that every time we stop recording the video, the game will reset to the initial state. Okay. And okay, I think most of the functions that we use as the game logic has been introduced. So let's gonna go to the on update, which is the central part of our game logic. Okay, so in the on update, we're gonna do several things. So one is to span the go break. So because on update you really do like kind of like the real-time stuff, like the animations, like the game logics, like we whatever we need to immediately um, respond to some game events, or some kind of like any logic related to delta time or frame-based logics, we put it into the on update. So there is a left go break and right go break here, and we can get the screen transform like what we did before. And then we're gonna have some mathematics calculation to calculate the rotation value, because it's a 2D rotation, so it's a single number here. The rotation number is gonna be the remaining number when we divide by 360, and it will uh, be the spinning animation of the two bricks. So if we save here, and we can see the two gold bricks start to beginning, and because the go bricks already have the collider attached, so it can already hit any other object also have the colliders. Yeah, so it's ready. So let's go to the next part, which is the ping pong animation for the vehicle icon when waiting for the user interaction. So that means this skateboard will start to have the ping pong animation from left to the right or from the right to the left when we have this part of the code. And let's see. So we will start ping pong from the beginning position to the end position here, which are both fixed positions in the 2D scene. And what we're gonna do here is to check whether we have the vehicle transform here, and also if the vehicle is not falling, because the vehicle falling marks as the flag Boolean property to mark this as falling state, but right now it's not falling, it's in the initial state, and the final vehicle is not enabled, which means the game is not over because we are just the start of the game. And if this vehicle is pinning, which means ping pong, it's going to from the left to the right, which means pinning, and from the right to the left is pawning, and we're gonna interpolate this from the start point to the end point. And if it goes backwards, it will go from the end point to the start point, which is kind of easy to understand by using this get current value that we just implement above as the mathematics utility function. Okay, and if it reached to the end of the animation, so there are kind of like two cases. One is when it's bigger than the like kind of like the pinning duration. If it is the duration of, because we have to fix the duration to go from left to right, and when it when it goes above the duration, we can have this toggled to the other side, and the pinning is false, and then reset the time. And also otherwise, it hasn't reached to the end yet. So that means we need to just add the delta time and go to the next frame when it calls the on update again. We'll calculate again to see whether it exceeds the time. So that will work here as the basic physics animation of the ping pong. And so, yeah, and the next part is when there is the final result comes, which means the game is over, and we want to show up the final texture of the vehicle as the final result, and we want it to scale kind of like as a ping pong animation here. And very similar, we have a very similar calculation logic here, but just to change the position interpolation, kind of like anchored position here into a scale calculation. Just use the scale as the kind of like the parameter we want to change, and then local scale to set to something we just calculated from the ping pong animation and reset it as the very similar logic like above, and then we can get it. Okay, and yeah, that's about what we need for the update here. And finally, don't forget, we will need to clear the subscription when this script got destroyed. That means when the game is quit, or when we just in the editor we kind of sometimes delete the object that has been attached with the script, or just simply delete the component it will call onDestroy. So the onDestroy will do the off for each of the event subscription, and also when there's a collider, we'll turn this off for the physics system, because physics system is still there, and then we'll mark this as off. Yeah, that's about it. And let's see. So as I just mentioned, you guys can change the score on hit to make this game kind of like the scores can go up faster or slower. And if I set it to 0.1, you guys can see, like, if I start recording and let it go and it will hit both bricks. It will change the texture of the vehicle when it gets to the next level. And if you think this is go too slow or too fast, you can adjust the number, and the final vehicle will have the ping pong scaling animation here. And yeah, that's about this template. Okay, that's all about today's video, and I hope you guys enjoy watching this video, and see you guys next time.